Hello! Welcome back! O diba, na-upgrade ang profile picture ko rito. Pero nagbago man ang picture ko, di naman nagbabago ang pagmamahal ko sa inyo. Kaya nga, gumawa ako ng panibagong video para matulungan kayo sa inyong SLM. O siya, tara na! Topic for today is special factoring. Special factoring because you are special to me. Hindi. Seriously, it is called special factoring because they cannot be factored the usual way. We have to follow a special pattern to factor them. Special factoring siya kasi di siya nag-factor ng normal na ginagawa natin. Nakatulad nung nasa unang video na may pag-list ng factors. This special factoring I'm talking about is difference of two squares and the sum and difference of two cubes. Let's begin with difference of two squares. First, let us determine in which polynomials can we apply the pattern for difference of two squares. From the pattern's name, we can say that there are two squares with a subtraction sign between them. So does it look like this? No. The square we are talking about is actually a perfect square, a name we give to a term that has a perfect square root. Perfect square ang sagot kapag minultiply mo ang isang number or term sa sarili niya. For example, 6 times 6 equals 36. Minultiply ang 6 sa sarili niya. Ibig sabihin, si 36 ay perfect square and its square root is 6. Perfect! Kung marami pa kayong makikitang halimbawa mamaya. Here are the examples of polynomials where we can apply the pattern for difference of two squares. O diba, lahat sila may minus sign in between sa dalawang terms. E paano natin malalaman kung perfect square nga ang dalawang terms na ito sa polynomial? Like the x squared and the y squared. Remember that x times x is equal to x squared. So x squared is a perfect square and its square root is x. Also, y times y is equal to y squared. Therefore, y squared is a perfect square and its square root is y. Same with a squared minus b squared. The square root of a squared is a and the square root of b squared is b. Ang square root ng m squared, m. Ang square root ng n squared, n. Pagdating dito sa m to the 4th at n to the 6th, wala silang squared na katulad nung kanina, pero perfect square din sila. Kasi remember, ang m to the 4th ay product ng m squared at ng sarili niya. So m to the 4th is a perfect square and its square root is m squared. Ganon din sa n to the 6. Kaya, for variables, para mas madalian kayo pag-determine kung perfect square sila, kailangan positive ang exponent at even ito. Pag sinabing even, nadidivide siya exactly by 2. So, n to the 6 is a perfect square and its square root is n cubed. Kasi 6 divided by 2 is equal to 3. Let's move on. Si d to the 12 naman, ang square root ay d to the 6th. Kaya perfect square din to. Ang e to the 10th, ang square root naman ito ay e to the 5th. Kaya, perfect square din siya. Ano ulit ang square root ng x squared? Correct, x. Then, the square root of 4 is 2. The square root of y squared is y. And the square root of 9 is 3. So, how about 25p to the 4th? O yan, pag pinagsama ang constant at variable, dapat parehong perfect square. Remember that 25 is equal to 5 times 5, kaya perfect square din siya, and p to the 4th is equal to p squared times p squared. Kaya ang square root ng 25p to the 4th is 5p squared. Ano naman ang square root ng 36w to the 6th z to the 8th? Ang square root ng 36 ay 6, and the square root of the variables ay w cubed z to the 4th. So the square root is 6w cubed z to the 4th. So alam mo na kung saan natin pwede i-apply ang difference of two squares. Now, let us factor. An example in the module is a squared minus b squared. We have two quantities for the factors of a squared minus b squared. So let's have those parentheses. Let us now fill in the parentheses the correct factors of a squared minus b squared. First, let's get the square root of a squared. The square root of a squared is a. We will write this as the first term of the first quantity and the first term of the second quantity. Next, let us have the square root of b squared. The square root of b squared is b, and this will be the second term for each of the quantities. Now, let us use the difference symbol between a squared and b squared as a clue for our next step. A negative number is a product of a positive and negative number, so we will write plus and minus between a and b. So the factors of a squared minus b squared are the quantity a plus b and the quantity a minus b. It can also be interchanged. So it can be the quantity a minus b multiplied by the quantity a plus b. So walang problema kung ang nauna niyong sinulat ay plus or minus. Next example in the module is 9x squared minus 25y squared. So again, we will have two quantities, and let us get the square root of the first term. The square root of 9x squared is 3x. This will also be the first term for the next quantity, 3x. Next, the square root of 25y squared is 5y. So we will write again 5y for the next term. Then, just like earlier, we will use this as a glue. So we will write plus and minus sign for each of the quantities. So the factors of 9x squared minus 25y squared are the quantity 3x plus 5y and the quantity 3x minus 5y. So they can be interchanged again, like that. So another example in the module is the square of the quantity a plus b minus 25. So again, just like in our first two examples, we will have two quantities. So let us first have the square of the quantity a plus b. So as you can see, a plus b is already squared. So it means we already have the square root. So the square root of that term is a plus b itself. So we will write a plus b as the first term of the first quantity, and we will also write a plus b as the first term of the second quantity. Next, what is the square root of 25? The square root of 25 is 5, so we will write 5 for both quantities. And again, the difference symbol, so we will use plus and minus sign. So the factors for this example is the quantity a plus b plus 5 multiplied by the quantity a plus b minus 5, or they can be written again interchangeably. So that's it. We're done with the examples in difference of two squares that are indicated in your module. So let us now proceed to sum and difference of two cubes. An example of this is y cubed plus 27. Y cubed and 27 are both perfect cubes. We have an addition sign, so it's a sum of two cubes. For the sum and difference of two cubes, you have to identify if the terms are perfect cubes. So y cubed is a perfect cube because it is y multiplied by itself 3 times. So the cube root of y cubed is y. 27 is also a perfect cube because it is the answer when you multiply 3 by itself 3 times. So it's 3 times 3 times 3. It's not 3, 6, 9, but it should be 3 times 3, 9, 9 times 3, 27. So the cube root of 27 is 3. Next example, x to the 15th power minus y to the 9th power. What is the cube root of x to the 15th power? X to the 15th is the product when you multiply x to the 5th by itself 3 times. That's why x to the 5th is the cube root of x to the 15th. Next, y to the 9th power is the product when you multiply y cubed by itself 3 times. So the cube root of y to the 9th power is y cubed. So as you can see, the examples here of variables are raised to exponents divisible by 3. Kung kanina sa difference of two squares, dapat divisible by 2. Ngayon naman, sa perfect cube, dapat ang exponent ay divisible by 3. So look, 15 divided by 3 is equal to 5. Kaya yun yung exponent ng cube root niya. Y to the 9th, 9 divided by 3 is equal to 3. Let us also note that x to the 15th minus y to the 9th is an example of difference of two cubes. So, let us now factor sum and difference of two cubes. An example in the module is a cubed plus b cubed. This is sum of two cubes, and we will have a smaller quantity and a bigger quantity for the factors. For the smaller quantity, it is a binomial, and the bigger quantity is a trinomial. So for the binomial part, let's have the cube root of a cubed, that's a, and then to complete the factor, let's have the cube root of b cubed. The cube root of b cubed is b. b times b is equal to b cubed. Then we will copy the sign of the given binomial. So the first factor will become a plus b. And for the trinomial factor, we have to square the first term of our smaller quantity. So a squared is a squared. Then we will also square the second term of the smaller quantity. So b squared is b. And we will write that as the last term of the trinomial factor. So for the middle term, we will multiply the first and the second term of the smaller quantity. So a times b, that's ab. Then we will just put the opposite sign of the one in the smaller quantity. So this is positive, and we will write negative for the middle term of the trinomial factor. And b squared remains positive. How about for a cubed minus b cubed, or difference of two cubes? We will just follow the same pattern. We will have the smaller quantity and the bigger quantity. So for the smaller quantity again, let's find the cube root of the first term of the binomial. So cube root of a cubed is a. Then we will also find the cube root of the second term. Cube root of b cubed is b. We will copy again the sign of the given binomial. That's minus. So we will also put minus in the smaller quantity. Then for the trinomial factor, let's square the first term of the smaller quantity. That's a squared. Square the last term. That's b squared. And for the middle term, multiply a by b. The answer is ab. It's opposite the sign of the smaller quantity. That's why it's plus. And b squared remains positive. That will serve as the pattern for the sum and difference of two cubes. Another example in the module is x cubed minus 64. This is difference of two cubes. So again, we have the smaller quantity and the bigger quantity. For the smaller quantity, find the cube root of x cubed, that's x. Find the cube root of 64, that's 4. Then copy the sign of the binomial. Then for the trinomial factor, we will have square of the first term, square of the last term, and then multiply the first and the second terms. Then, since this is negative, we will put positive for the sign of the middle term of the trinomial factor and keep the sign of positive 16. Thank you for watching. Till our next video. Bye!